Hello AS Math, it is Mr. Knight bringing you exercise 2D fresh out of the oven, intersection of lines, okay? So do not let the title of this fool you. This is actually kind of a hard problem set, okay? Luckily, we've actually been kind of doing intersection of lines without explicitly saying it, but you'll get to see it explicitly now, and you'll see what I mean in a little bit, okay? So our two skills are calculating where two lines intersect, and the second one is yet another shape application problem. Yeah, they're not going anywhere, guys. Sorry about that. But we still have to work with them, and they're not too bad the more practice we get with them. So I have a challenge for you guys. If you're in class, you're definitely going to do this, but if you're at home, I encourage you to pause the video and try it. I want you to try to draw two lines so they cross twice. Give it a go, and let me know what you come up with. This is what I've come up with. Okay, probably looks a lot like yours. Okay, your two lines, and then maybe you try to get a little creative. Maybe you're like, I'm just gonna do this, and like, no, you can't do that because now there's 1, 2, 3 lines. Okay, only 2 lines. All right, so back to the drawing board. You draw your line. Maybe you try this. Maybe you're like, hey, I'm gonna do this. I'm gonna just take my line. I'm gonna wrap it around. And hey, I just made it do it twice. Ha ha ha, Mr. Knight. Well, if you did try to do that, kudos to you. But that is true on a basketball or the earth. Like if you have lines of longitude and latitude, yeah, eventually those lines are going to intersect twice. But then we're not in 2 dimensions anymore. And I guess you're kind of right, but it's not really a line at that point. It's a curve. So it was probably a valiant effort, and I appreciate your attempt, okay? But you can't actually do it. There's only 2 possibilities, and here they are. Your 2 possibilities of line intersection are they are either parallel, meaning their slopes are the same, and they will never touch or intersect, or they will intersect, but only at a single point. So their coordinates of that point for this line will equal the coordinates of that point of that line right there. So their coordinates will be equal to each other. Now you're looking at this and you're like, 1 equals 3. No, it doesn't, Mr. Knight. What are you doing, dude? Bringing you to Desmos. Let's take a look at what I mean. So let's say you have parallel lines and you want to find out where they intersect. So you equal those lines to each other. You do 3x plus 3 equals 3x plus 1. Algebraically, you solve for x. Well, there you go. Now your x's are canceled out because your 3x's are gone, and you're left with 3 equals 1, which obviously is not true at all. Okay? So if you run into that situation where you're trying to find the coordinates where 2 lines intersect, and you did the math right, and you're noticing you're getting one value equaling another value, and it's clearly wrong, you probably have a case of parallel lines. Okay? So we're actually going to take a further look at We're going to look at number 2 right here and kind of see what that looks like in the context of a problem. So let's do that. So skill 1, this is where 2 lines intersect right here. We're going to find the coordinates of the vertices of a triangle whose sides have the equations, those guys right there. And they're all written in disgusting standard form, but we are going to work with it in standard form because I've kind of turned over a new leaf and I see that they have some usage, a little bit, just a little bit. And we're going to use them right now, okay? So let's sketch this actually. We don't have to, but it's really helpful to do so. Let's sketch each of these lines. I'm going to color code them too for you. If we're starting with x plus y equals 4, and I need to get a line out of that without turning it into y equals mx plus b, I can do that by getting the x and y intercepts. How do I do that? Well, if I want the x-intercept for this first equation, all I got to do is plug 0 in for y and solve for x. So I do that, and x equals 4. So that means 4, 0 is one of our points for that line. And we can do the same thing for the y-intercept. I plug 0 in for x, y equals 4. So 0, 4 is my y-intercept, and there. I got 2 points, and that's all I need for a line. Actually, I'm going to just continue that on. Okay? You'll see why in a little bit. So that's our first one, and let's just continue that process, right? So 2x minus y equals 8, I plug 0 in for x, and I get negative y equals 8. So y equals negative 8. So 0, negative 8 is one of my points. It's my y-intercept, and it's right here. Now I plug 0 in for here. 2x equals 8, x equals 4. 4, 0 is one of the other points, and hey, there's one of our vertices right there. As soon as I draw this line, and hopefully I draw it. Oh, God. I spoke too soon. But luckily, that's one of our vertices right there. Okay, as you can see, they're intersecting at 4, 0. So that's good. I'm going to start labeling my points because, hey, they might actually come in handy. Who knows? Okay. And then our last one. X plus 2y equals negative 1. Let's plug 0 in for y. X equals negative 1. So negative 1, 0 is one of our points. And that is black. There we go. All right. And then I plug 0 in for this guy. 2y equals negative 1. So y is going to equal negative 1/2. So be right there. And wow, those points are really just chilling by each other. Now I'm going to put this guy through here. And boom, that's why I extended that line, because hey, it wouldn't have been obvious if this was a triangle. Okay, so we have an intersection point right there, and hey, we already have that guy right there, huh? So I know that 4, 0 is one of our intersection points, so I'm going to write that down. Now it's about finding the other ones, and well, we can do that by elimination, actually. If you remember from simultaneous equations, we were able to basically look at two equations on top of each other, and we could use elimination to solve for the x and y's of those. Well, now we're just doing that, but in a more graphical context. So if I'm trying to find this guy, this vertice, well, I know that's where the black line and the orange line intersect. So that means these two guys are going to be the ones that I'm going to work with. So let's do that. So I'm going to take 2x minus y equals 8. I'm going to take x plus 2y equals negative 1. And now, looking at this, looks like we can solve it with elimination pretty easy. Because all we got to do now is I could take this equation and I can multiply it by negative 2. So if I do that, I get negative 2x minus 4y equals positive 2. And now we just have to combine by adding and subtracting. I go ahead and do that. I get negative 5y equals 10. And now y equals negative 2. And so now, if I want to find what my x-coordinate is, I just take this guy and I could throw it back in one of these equations. So I'm going to do that for the second one. So I do x plus, well, it's negative 2 times 2, so it'd be negative 4. So this is really minus 4 equals negative 1. And then I add my 4 to both sides, and I get x equals 3. So that means this point right here is 3, negative 2. And that actually kind of makes sense, right? 3, negative 2. It's somewhere in that domain, right? Somewhere in that realm. Just my sketch it isn't perfect, so it's got its limitations there. So that's one of our other points. I'm going to write that guy down. And finally, we could do that for this last point way out yonder, way out here, okay? So that's the black and blue line, and again, I'm going to repeat this process. Now, I know what you're thinking maybe too. I don't know what you're thinking, but maybe you're thinking about this. Can I substitute, Mr. Knight? Do I have to do elimination? You absolutely can substitute. In fact, let's go ahead and substitute now. What's a good thing to substitute? Well, let's look at this first equation, right? This is our blue line right here. And so I'm going to set it as y equals 4 minus x. Okay? And now I'm going to plug that guy in for this second equation. So now I have x plus 2 times 4 minus x equals negative 1. And then we continue on. All right, x minus 2x, that's negative x. and then I subtract 8 to both sides, it equals -9, so x equals 9 right there. And again, same thing. Like I did over here, I did it with y over here, but I'm doing it with x. I just take this guy and I throw it back in. I'm going to do it for this first equation. X plus 9 equals 4, so x has to equal -5. Or, I'm sorry, if it's 9 plus y equals 4, I'm just going to write it down, so you know what I'm substituting in. Subtract both sides by 9, I get y equals -5. So that point is 9, -5, and again, that does make sense. So those are our 3 vertices of our triangle, and this problem is solved. Okay? So it's not too bad. At least like with the substitution elimination, once you kind of like get a sketch of your triangle, and I always recommend sketching when you can, that'll help you figure out, you know, what goes where and whatnot. And you're seeing that there's a lot of these concepts are kind of converging onto like into each of our problem sets now. Like this was an algebra concept, simultaneous equations. So they are coming back, which is why we started with it, kind of get you guys going. So now let's see something that's a little bit trickier, something not as obvious, right? Not to say that that one was obvious, but something that's a little more technical, let's say. Okay, shape application. So a median of a triangle is a line joining a vertex to the midpoint of the opposite side. In any triangle, the 3 medians meet at a point. The centroid of a triangle is at the point of intersection of the medians. Oh, that's a lot. So pretty much what's going on is a median is from your vertex to the midpoint of your opposite side. So it'll go something like this. And there's one of my medians, but I have 2 more. Every triangle has 3. So I repeat this process, and we are just about done. And so where the 3 actually intersect, that's called the centroid right there, okay? So we're actually going to try to find the coordinates of the centroid using this information here, okay? You have a problem like this, like this on your homework, so that's why we're going over it, okay? So anyway, we actually need to figure out what we need to find. So we need to find this. That's good. But we need equations of these lines, right? Because if I have like the equation of maybe this guy right here, and I have the equation of this guy right here, and I set them equal to each other, or I solve for them using elimination or substitution, then I'm going to find the coordinates of that guy. Well, I don't really have the equation of the line yet. I only have 1 point for this first line right here. Okay? But I do know that it goes to the midpoint of the opposite side. That's where the median goes. So this is actually a midpoint of these 2 coordinates right here, or these 2 points right here. This is a midpoint. And you can throw it into your midpoint formula, which you totally can do. And I'll do that for this first one. So your midpoint is going to be the sum of your x coordinates, so 0 plus 0 over 2. And then the second one's going to be 12 plus 0, the sum of your y coordinates divided by 2. And so you'll get 0, 6 as your midpoint for right here, which makes sense. Okay? And then you do the same thing, but now for this midpoint here, okay? Because we want the equation of this guy. And again, you could do that, or you can just see that 3, 0 is the midpoint. Okay? So now we actually have 2 points for each of those lines, and now I can actually create their equations. So for this first one right here, okay, and we'll do this one right here, I need the slope. So the slope is your y2 minus y1 over x2 minus x1. So I'm going to call this my x2, y2. So this is going to be 0 minus 6 on top, and this is going to be 6 minus 0 here. So then we end up getting -6 over 6, which is just -1. And so now we have, for our equation, we have y equals -1x, or -x plus b. And now I need my y-intercept. But we know what our y-intercept is, right? It's actually this guy right here. It's got an x-coordinate of 0. So my equation for that line is negative x plus 6. Okay? We'll kind of circle that for now. And we're going to repeat this same process, but we're going to do it now for this line right here. I'm going to call this my x2, y2. This is going to be 0 minus 12. This is going to be 3 minus 0. So 12 over 3 is going to give me 4. So this equation is y equals 4x plus b, but we don't need to write b plus b because we know the y-intercept is 12. So now, from here, you can go ahead, you can do elimination, but I would personally do substitution. I think it'd be easier in this case, right? Because what I could do right now is I have y equals this. I can just plug negative x plus 6 in for my y. Let's do that. Now let's just solve for x. Okay, so I move my this guy over, the plus x on both sides. And I'm going to move my 12 over. So I get negative 6 equals 5x. Did I do that right? Let's see. 1 second. Alright guys, I saw my problem. This guy's supposed to be negative. My bad. It's like, that is not working out the way I thought it was going to work out. Okay. So now let's try this again, right? So we got negative x plus 6. We're going to equal that to 4x plus 12. It's a negative 4x. Okay. Now let's go ahead. Let's move the x over. And let's move the 12 over. So we get negative 6 equals, this will be negative 3x. And now x is going to just equal 2. It's supposed to get a nice answer of 2, not, 5, 6, or 6/5. That would have been weird. So now I have x equals 2, and now I can just throw that into either equation. I'm going to do this one. So I get negative 2 plus 6. That gives me y equals 4. So that means my centroid has coordinates of 2, 4. And there we go. That's the answer to that guy. Again, that makes sense. 2, 4. Hey, that's somewhere in that realm right there, okay? Go ahead and get going on your homework and let me know if you need help.